The day 3 of Advent of Cyber. And today's challenge, we are talking about log analysis. Now, before we get into log analysis, let's go through the storyboard of today's challenge. And that is, it's almost Christmas in Wavell, and the team of the best festival company is busy preparing for the big celebration. Everything is running smoothly until the SOC dashboard flashes red. A ransom message suddenly appears. Attack 1000 Hopsec coins for Mix Kitty or Sockmas ends tonight. The message comes from King Malhare, the jealous ruler of Hopsock Island, who's tired of Easter being forgotten. He sent his band bunnies to attack the best festive company's system and turn Christmas into his new holiday, Eastmas. With Mixed Kitty missing and the network under attack, the best festive company SOC team will utilize Splunk to determine how the ransom infiltrated the system and prevent King Malhare's plan from being compromised before Christmas. So that's our story here. Now, what are our learning objectives for today? It is to ingest and intercept custom log data in Splunk, create and apply custom field extractions, use search processing language or SPL in short to filter and refine search results, conduct an investigation within Splunk to uncover key insights. And they've told us that we'll be requiring some VM and direct links. I've already booted them up and we have an hour of time to finish that. Okay, so let's click on the check option here and move to the next part of the log analysis. Exploring the logs. In Splunk instance, the data has been pre-ingested for us to investigate the incident. On the Splunk interface, click on search and reporting on the left panel as shown below. Okay, for that we need to open the link here, which I did not do it earlier. Let's open it here. That should take us to the Splunk URL. And let's come here. Do we have the login credentials shared here? Let's check for that. No, I don't see any login credentials, which means that it's going to automatically go to its page. And we get this Splunk page where we can actually analyze data, which is already embedded into this. So all that we have to do is click on the search and reporting button here. That is going to ask us what do we actually want to search. Now let's read through this so understand what exactly we are doing here. On the next page, type index is equal to main in the search bar to show all ingested logs. Note that we will need to select all time as the time frame from the drop down on the right of the search bar. Let's do that. Let's type index is equal to main and press enter. That's going to show off 24 hours. To change that, let's come here and click on all time and search for it. So this is basically the entire log, which is of the main log file. Now here we see a lot of parameters and a lot of data is just on our screen. Now for the first time looking at this Splunk's data, we might feel overwhelmed, but it's quite simple and more organized compared to like how Grafana and other applications do that. Now here we have some selected fields like host, where we can look at what are the hosts that is being accessed, the sources, the source type, and some interesting fields also like the client IP address and the hours, and all those information is just given here. But this is the entire data which is present inside the log, right? We want to get specific about it. That's where we go in here, which says the two data sets are as follows: web traffic and firewall logs. And we can see that here. We see that the source type of all of our data that we are seeing currently are of either web traffic, or scrolling down here, we see firewall logs. And they're all those sets of information that is being presented to us. Now, for this, start a basic search across index using custom source type as web traffic using the following queries. Now here we can filter exactly to what kind of information do we want to see. Now we want to ignore all the firewall logs as of now to see how the attacker exfiltrated into our machine. So we'll paste in the extra filter which we copied from the page of TryHackMe here. into the Splunk, and all the other parameters remain the same. Let's click on search. It says all related to web traffic itself. And here we can see the host again, the sources, the source type, and even the interesting fields like what are the clients who were accessing the web source and web traffic was being noted. Or we can even look at the indexes which were being asked, which was being shown. Now, in this case, we have mentioned that index is supposed to be main. All that information is present here, and many more information can be looked from that place. We can also put that down and we can see the source type, host, and exact parameters of the traffic that we are seeing here. Let's go to the page here, and they've broken down the same thing. Now they've given us little more detail about what I just said, which is this query retrieves all events from the main index that were tagged with a custom source type to be web traffic. This marks the beginning of the investigation. This area of searching is called as the search query. Then comes the time range. It's the range to set all. In security analysis, this range would be tightened. Example with the spike window after initial data loading. So this is the time frame. Now, when we're trying to analyze the data, we would go for very specific event of time. When we notice that actually there was a specific attack happening at this hour, we would try to cut it down and then string the analysis to that window of frame that we want to analyze and look at the data here. But in our case, we want to look at all, so that we want to looking at all the data, we want to start coming down from the huge data by funneling and filtering through what exactly we need. Now the timeline, this is a visual histogram, shows the distribution of 17,100 some events over time. The graph indicates the successful daily log volume followed by a distinct traffic spike. So this is the spike that they are talking about. This is the event. Now we can see over the period of 20 days from October 1st to October 21st, we see the data being split here. And we can see on very specific day like October 10th, there was a huge spike. Also on October 12th. So this would be the time frame when majority of the attacks were conducted, as we can see from this graph here. It's going to give you a very specific source of identification of the volume of traffic. In our case here, web traffic is being presented to us. Next, the selected fields. These are the fields currently chosen to display the summary columns of the event like host, source type. They represent basic metadata about the log file itself. So this is nothing but the files contents which are mainly categorized under it. Now, interesting fields. This is the panel list of all the fields Splunk has automatically extracted or manually added. The fields prefixed with a hashtag are automatically generated by the Splunk's time command. The presence of user agent, path, and client IP confirms the successful passing of web log structures. So we can see here, any web request that is going through, it's going to have things like the client IP addresses, the user agents, the host, and such informations. They're also categorized here. We can see that from client IP here. We have a list of so many IPs which has communicated to the server that we are actually looking at the web traffic of. Or we could even filter through user agents here. What are all the user agents which were identified by Splunk that came under the web traffic category? Also the path here, we can see this is the paths which were identified by Splunk that was mainly accessed, and we can even see the number of counts, the percentage out of the total traffic that was being captured and analyzed. All those informations are present there. Now, event details and field extraction. This section shows the past details of a single event with the extracted fields like the user agent, path, status, client IP, and more. That's the main data that we saw here. This is those information that is shown of that web traffic. Now, visualizing the log timeline, let's chart out total event count over time grouped by day to determine the number of events captured per day. This will help us identify the day that received abnormal number of logs, and they have shared us the query. So we need to filter out and look at when exactly did we get huge number of requests. Now clearly we can see it on these days, but in case we had a varying graph, varying structure of logs which were being captured in the tool, we would want to filter it. So we have this option here. We'll continue with time chart. Span is equal to 1 day. We are filtering it from the 20-day span into 1 day each as a count frame that we want to see, and then they're providing it to count for it. Let's copy this and also add it here. Press enter. We can see the statistic loads up according to the timeline. So it's on 10th of October. This just shows from the day 1 to day 20. But if we have to sort it, we can add another line called as sort by count. So that's going to sort it according to the count which is present here in an ascending order. Let's also add it. If I can sort by count, press enter, and we can see that it has arranged it according to the ascending order of the number of counts which was being passed. And we can see 10th and the 12th were the most days where we received a huge number of logs there. Okay, that's good. Now let's click on the visual. The above results are shown. No, the above results are now showing event logs captured per day. This could be interesting as we can see some days getting high volume of logs. We can also click on the visualization tab to examine the graph for better presentation as below. We can do that by going to the option of visualization here, and this will load up the graph. We can see that on 12th we have the most number of count, and on 10th we have comparatively again more number of counts of volume of data being passed in. This is again sorted in ascending order due to our query that we have passed in. Now here we can append the reverse function at the end to display the results in descending order, showing the day with the maximum number of events at the beginning. So we have sorted by count. We can also add another parameter of reverse. Let's do that, and it's called as reverse. Press enter. That's going to, let's open statistics, and now we can see that the count of 12th is shown in the beginning rather than it being in the last. That's, we can identify now that 10th and 12th are going to be a primary source of looking at any data present in it. There's a clear period of intense activity during King Malhare launched his main attack phase. Now, when you're trying to attack any organization or any web application, it's not about the one file that we want to find, but it's also about the process that we take or the approaches that we make of identifying what are the fields and parameters which is present in the web server, where are the places where we can try to exfiltrate it. So they generate a lot of logs and a lot of data and web traffic to the server, which where if we have any sources which can log all those traffics, we can clearly see a huge spike just going out. When you try to even perform an nmap scan, you can see a lot of traffic just going randomly to that target server with a lot of requests and service availability checks which the tool does. So it generates a lot of log. Now that's what is happening here. By this, we can now filter out that from 10th of October to 14th of October was maybe the time frame that the attacker chose for exfiltrating into the web traffic or the web source server. Any other day, it just looks a quite normal number of traffics being passed. Now, the anomaly detection. Now that we have examined the days with the abnormal logs using the table and the graph, let's use the same search query to examine various fields to hunt for suspicious values. We need to go back to the events tab to continue. First thing, they're looking at the user agent. Let's click on the user agent field in the left panel as shown below. It will show us the details about the user agents captured so far, which we have already done it here. We could Again, go back to events here, then click on user agents, and we see that already present here. We can see that the count of top 10 values being presented, with Mozilla Firefox or Mozilla user agent being used on an iPhone, then on a Windows machine, Macintosh. There's a wget, which is even querying for some traffic. We can see thousands of queries coming from that. We can also see curl doing a request to the web server, again in the number of thousands. Also go to clients, and some automated SQL injection tool is also trying to look or do some scanning. It's approximately towards thousands of requests. Also SQL map, which is a tool used for looking at any or exploiting any SQL injections and SQL parameters in a web application. Those are all in the numbers of thousands, which brings a lot of suspicious to us. Now, going through this, we also see that client IP address is one of the other key element which we can look at. If we come here, we can select that, and we see that there is one specific IP address which is having a very huge number of count of requests. That is this IP right there. It's around 7,876 counts of it. Others are in the category of 3 or 2 requests a day. So that is a suspicious thing. Now, this could be a production server itself communicating to something where it requires so much of requests to do. We don't know about it, but that brings us a suspicious look after this IP address. Now, scrolling down, we want to also see the paths which were searched and queried into the web server. So we can click on the path here, and we see the normal paths like the index, the blog pages, the root of the web server, static app.css, shops, contacts, and such general things, which is actually being used on a day to day operation. But there is something very, very suspicious, which is download file is equal to dot slash etc pass wd. Now, if you're new to this hacking stuff, now this is called as looking at the password file which is present in any Linux server, wherein you can get the list of users who are present in the server. Or we can also see some SQL injection happening here, where I can see they're trying to send the server with the SQL query, which is going to make the server sleep or break for 5 seconds before it starts to respond back to us. Now, that's usually used for any Boolean way of trying to see if there's a SQL vulnerabilities or trying to exploit it in such ways that if it is vulnerable, it's going to delay the response that it gives us in 5 seconds. So, all such suspicious things are happening here. We also see that they're trying to look for some ID which is equal to 1. They're also doing some test, that too in the numbers approximately towards 600 of requests. That's a suspicious log that we're able to see here once again. Now, filtering out begin values. We know King Malhare's bunnies use scripts and tools, not shared browsers. We know King's Malhare's bunnies use scripts and tools, not standard browsers. Let's filter out all standard traffic. Now, they've given us the queries here. Now, when we're trying to perform any kind of exfiltration into web applications, we generally use tools rather than browsers. Now, we do use browsers, but if you want to do some automated scannings and automated exploits, that's going to be either through wget or any custom script which is written using Python or C or anything like that. That is what we are trying to filter, making sure we don't take in any user agent which is anything which has the word Mozilla. Mozilla is nothing but the Firefox that we are using for accessing it. All those username or any Chromium based user agents, or even anything which has Safari, which is the most popular user agents which we can see when a web application is being accessed. Let's copy this and make sure we want to see only the contents that doesn't have all these user agents present inside them. So now let's click on search. What we see here, all of these are the user agents, which are anything other than the Mozilla, the Chromium or Safari or Firefox in general. We see we have wget, we have curl, we have SQL map, we have some automated SQL injection, we have Python scripts, we have even Ruby scripts trying to access our web server. That's good. Now we see a lot of values. We can also look at the client IP, which just says one IP is doing it. All these are being accessed by just one IP. And that's what we see here, that we are identified with a huge number of requests being sent, is around nearly thousands of requests, that too using these unknown and suspicious user agents there. Let's also look at what paths were being accessed by this tool. Again, we see that they're trying to do some SQL injection, trying to look at the etc pass wd files. This is another URL encoded SQL injection they're trying to access, trying to redirect into some other URL or website, and all such information is being presented here. This gives us a clear understanding that the current IP address that we have found is the attacker's IP address itself. Now let's narrow down things and see what exactly did the IP address start doing there. Now, they've given that in real world scenarios, we often encounter various IP addresses constantly attempting to attack our servers. To narrow down on the IP address that does not send requests from the common desktop or mobile browsers, we can use the following query. Now, we have already identified that, but they have shared us the command which would help us filter this directly to the IP address. So, what we're doing here is that we are again selecting the web traffic, then the user agents. We are removing all the popular user agents out of our search. Then we are giving the count as by client's IP address. It's going to just show the status of it and sorting it with the command of count head 5. So let's press enter. That's going to show us the IP address of who's having a huge count. Now generally this is run because in any environment where we have many users trying to access our servers, we could have these kind of user agents who could not be used by like the Mozilla or the Chrome or any such user agents. We could have a genuine Python script running in the data center or any server which actually checks for the status of the other servers which are just living on the same network. Now those might also start sending a huge number of web traffic, so it always becomes a key point that we verify that these machines which we are trying to flag as the attacker's machine or the suspicious IP addresses are not the genuine are not the genuine IP addresses which are required for operational works. That's the reason we are trying to filter out by the number of counts. But in our case, this IP address is an external IP address which is just trying to look at and scan for the contents which is present inside the server. Now, the result confirms the top IP address used by bandit bunnies. In the search queries, the hyphen in the sort count part will sort the result by count in reverse order. It's the same as using reverse function. Let's pick this IP address and filter out to see what footprints of the activities captured. Now we are trying to look at what are all the steps that this IP address was doing all along. Now tracing the attack chain, we will now focus on selected target IP to trace the steps chronologically, confirming the use of multiple tools and payloads. Don't forget to replace redacted with the IP we noted down previously. What we'll do is let's copy the IP address which is present here and open up, let's say, text editor and paste the IP address there. Now they've given us the reconnaissance that we are trying to do here. We are more of trying to analyze what the attacker might have done in our server using many more filters with the basically with the path parameters in our search. So let's copy this query. Let's analyze it before we actually pass it to the Splunk search query. Let me paste that in here. Now, again, the beginning is about the source type, which is the web traffic that we are looking at. And now we are talking about the IP address, the one which we want to see what this IP address was doing in web traffic. Let's copy the IP address and replace it in the client's IP address parameter here. Then, and it's also going to compare the path in which it was looking at. Was it looking at any environmental variables? Was it looking at PHP info or .git or any such parameters of path? Was it trying to look at it? And then we are using the table time path user agent status. So those are the outputs which we will be getting by running this query. We want to look at the path, user agents, and statuses of it. Let's press come to this tab here, paste this command here, and we see one is the timeline when it was happening. Then it shows about the path which it was accessing, which we have already mentioned it there. Then the user agent, what was used for accessing these paths. Then last we can see the status. What was the status? Now, just because the tool has been running, it doesn't mean that they have actually found into those paths that is shown our log. Now, those paths might have been attempted to search, but they could be redirected, or they could give us an error saying 404, which means the attacker would have not actually been able to access those files. That's what we can see here. We can see php info.php has not been found with the wget command to our target on this day. That's a good thing. Now, this helps us to understand what exactly are the paths and files which might have been handed over to the target attacker, right? That's where we are filtering and looking at the paths and the statuses of this log. Now let's scroll down, and it says the result confirms the attacker used low level tools like curl and wget and was met with either 404 or 403 or 401 status codes. Now, they are the web servers related to not being able to find out any kind of files, is what the error is going to show to them. Now, let's talk about the enumeration. Now that we have understood about what the attacker might have got through in their reconnaissance phase, now what might have the attacker enumerated with? Now, let's look at the vulnerability testing here. Once again, let's copy the query here and replace this query in our text editor with the existing old one. Here it's again talking about web traffic, then the client IP address. Let's copy the client IP address once again to see where our attacker was heading through. Now let's replace it here. And now we are looking at any path. Again, why are we looking at path with dot here? The star shows that it could be anything before it and anything after it. So we wanted to make sure and see if there's any dot being used. Now, any system which is vulnerable to either local file inclusion or directory traversal, we could look at the files which is just present in that server. Let's take an example of it. Let me open up a terminal here, and let's say I run a file. Let's go to my directory where I have TryHackMe's content. Let me see where can I go. Let's go to let's say Shakers, and here we have so many files in that. Now I'll run a basic simple Python 3 command, which is going to host a simple HTTP server on port 80. Now if I open up the browser and say 127.0.0.0.1, okay, this is going to do a directory listing of all the contents which is just present in the server. Now, if my application is vulnerable to something called as local file inclusion, I could use these commands like //// so many number of times till I hit the root directory of the server and then call for the etc parse wd file. Pressing enter, it says 404, means it did not find, because now Python basically doesn't allow us to get the etc parse wd file. Again, if you had URL encrypted it, it would have just shown it us. But in our case, because Python is going to ignore all those // parameters, we are not able to access it. But that actually is parameter which any attacker would use to identify and see is there any suspicious file that we can actually get, and then we can exfiltrate it. And mainly if you get the etc passwd file, we will get some usernames that is present inside the server. I could just print out my etc passwd file, and here we go. We can see all the users who are present inside the machine here. Okay, with that, let's come back to what we have in our Splunk here. We are either filtering for the path which has dot dot slash in it, either looking if they're trying to access any other file other than what is actually supposed to be accessed, or we are looking if there was any redirect in the path which just happened. Now let's search with this query and look at what we will get, and then we can see where we can go forward with it. Now, if you look at this, we can see that the post request was being sent to either capture the etc passwd file, which they were successful. If I can see it with the code there, it says 200, right? The status is says 200, which means that yes, indeed, the attacker got the etc passwd file. Also, we can look at any redirects which just happened with this parameter here. We can see that the application was told to redirect to HTTP evil site, and that came with a 403 error. Now we are able to see how the attacker here is trying to exploit into our server by either looking at these etc passwd files or trying to redirect the server to download something which they would want it to run like a reverse shell or something which would run as a script. The output shows the resources the attacker is trying to access. Let's update the search query to get the count of resources requested by the attacker. This search query is filtering on the path that contains either dot dot slash dot dot slash or the term redirect in it. As shown below, this is done to look for the footprint of path traversal attempts. 2, we need to update in the search query to escape the characters like dot dot slash. So it's basically now we are going very specific with the contents that we just spoke, but also adding extra status which says status count by path. What we'll do is I'll just take this content here because all that we are doing is the same thing. Let's just add in this parameter here. This is going to show us the number of counts that these paths were being tried to access, and we can see they are in the number of 600s and 600 each, which we had already identified earlier with the left side of the panel. Now, quite interesting results reveals the attempt to read the system files, showing the attacker moved beyond simple scanning to active vulnerability testing. Earlier, we also saw that the attacker was trying to look at some SQL parameters by running some SQL injection parameters into the server. For that, we can also filter it using the user agents of either SQL map or HaveEG. Those are the popular tools used for doing some reconnaissance and exploitation with related to SQL injections. What we'll do is let's just copy this part of the search query from and then filter with the user agent instead of path this time. Let's replace that here, and let's see what were the parameters that they were trying to access using this user agents. So we can see that the path was chosen like the ID1 or ID with where they're trying to make it sleep or do some more with URL encoding, and all these are just happening here. We can see the number of statuses that they get, either 500, there was some total internal errors in the server, or they were also being getting a valid response by 200 there. Now reading through, it says that the above result confirmed the use of known SQL injection and specific strings like sleep. A 504 status code often confirms a successful time-based SQL injection attacks. That's true. So the attacker now knows that the server is vulnerable to SQL injection. What next are they going to do that? Search for attempts to download large sensitive files like backups or logs. So we can use the following query. Now that's what anyone who gets an initial foothold in the server, would try to download something which would contain either like a backup or logs or anything which would reveal any further exfiltration into the server. In our case, the attacker chose to go with backups or logs and those information. So let's also filter it using that. We are looking that if there's any word which is like called backup in the path parameter. Let's press enter, and we can see logs, and we can only see logs. So there is no backup as a folder or zip file which is present in the server. We can only see the logs being extracted using the wget and curl and goHTTP client as the user agents there. That's a good information that we are now getting. Now, the result indicates the attacker was exfiltrating large chunk of compromised log files using tools like curl and zgrab and more. We confirm the details about these connections in the firewall logs. Now, I guess we are moving towards the firewall logs. Not yet. Ransomware staging and RCE. Request for sensitive archives like log.tar.z and config files indicates the attacker is gathering data for double extortion. In logs, we identified some requests related to bunny log and shell.php. Let's use the following query to see what those search queries are about. So they've given us a search query. Let's first copy the search query and then just enter it here. Now it talks about web source traffic again, and then the IP client IP address basically. And here we are adding a new parameter, which is to see if there is any bin file or is there is any command line being accessed from the URL there. So let's replace the older parameters here and substitute it with our new parameter or the path that we want to look here. We want to look at the time, path, user agent, and the status of those either the bunnylog.bin file or the shell.php file. Now we see shell, it says who am I. It's basically, it's going to say which user is running. So which means that they have got a remote code execution happening in the server where they can pass in the commands into the server and the server replies with the system based answers to it. We can also see bunnylog.bin. So it's sending some binary files into the server using the user agents like zgrab or ruby or wget and all those user agents. We can also look at those logs here along with their status codes. That's sensitive information which an attacker is trying to gain here. The above results clearly confirm a successful web shell. The attacker has gained full control over the web server and is also able to run commands. This type of attack is called as remote code execution or RCE. The execution of shell.php command is equal to /bunnylog.bin indicates a ransomware like program executed on the server. I overlooked at that, but we can also see that here. It says it's telling the command to run the bunnylog.binary file. It's using through some Python request there. Correlate outbound C2 communication. C2 is command and control communication, which means that the server is trying to talk to another external server which the attacker has complete control over. Now that's usually the stages which any ransomware groups or any servers which require some modification or runtime execution commands to be provided uses these communication channels called as command and control servers for taking in more inputs. It's like the boss calling and telling the payloads and the tools in the exploited machines saying what to do next. So we see that in the firewall logs. We pivot search to the firewall logs using the compromised server IP address as the source and the attacker's IP as the destination. So we already identified the destination IP address, which is what we are using since then. That's our C2 server's IP address. They've given us a new search query. Let's copy the search query first and then analyze what are we actually looking at it. Let's paste that in here. And this time from the web, logs, web traffic logs, we are going towards the firewall logs, which the firewall would have noted it during the web traffic being passed or any traffic being passed in the network. Here we are seeing the source IP address, which is our server, in our case, the victim server's IP address, and the destination IP address is of our target server. Let's copy that and replace it here in the place of redacted. Okay, let's remove this and replace it with this. And action is equal to alert, which means that that action has happened, by that the firewall has allowed that connection to reach to the C2 server. Then it's all the other parameters that we want to see in the format of table, which is the time, the action, the protocol, source and destination IP, destination port. Destination port also gives us a lot of information about what kind of server is hosted there and the reason that the firewall allowed this query to go through. Now let's replace the existing query with a new one and press enter. We can see the time. Then we can also see it has allowed all these requests to go forward, and the protocol was used as TCP. TCP IP is the general protocol being used for any C2 channel communications. Now the source IP address is our target's IP address. It's what is trying to connect from to the destination or the target's IP address there. And we see that it's running on port 8080. It's port being open for any C2 communications. And reason is C2 contact. That's what was flagged by the firewall there. Okay, now going forward, this query proves the several immediate established and outbound connection to the attacker's command and control IP on the suspicious destination port. The action allowed and the reason C2 contact field confirmed the malware communication channel was active. Volume of data exfiltrated. Now we want to see what was the number and the volume of the data that the attacker just took away from us. So we are using a new query for it. Now let's copy this query here and replace it with this query. Now what we are seeing here is the firewall logs from our targeted server, not the target server, and the destination IP address is of our attacker's C2 server. Let's replace that redirected with this IP address, and the action is again allowed. We want to also now see the sum of the bytes transferred by the source IP address alone. So let's copy that. Now I've come back here. It says machine is expiring soon. Let's add another R. That should help us to finish this module successfully. Okay, now let's come here and replace it with this query. Pressing enter, we can see from the source IP address, which is our targeted server, has sent nearly sum of 1,26,000 and hundreds of bytes of data to the server, which means that around a gigabit of information was transferred to the attacker. Now the result shows a huge volume of data transferred from the compromised web server to the C2 server. So the conclusion of our analysis here today is that identity found. The attacker was identified through the highest volume of malicious web traffic originating from an external IP address. The intrusion vector, the attacker followed a clear progression in the web logs, which is the web traffic. Then the attacker performed a reconnaissance to provoke and initiate using these user agents like ccurl and wget, looking for any environmental variables present and even testing for any path traversal vulnerabilities. Exploitation was done using SQL map with the parameter of the sleep. Exploitation of SQL injection. Then payload delivery, the action objective was established by finally successful execution of command, the cd bunny log.bin through the web shell. And C2 confirmation, the pivot to the firewall logs. The source type is equal to firelogs provided the post exploitation activity. The internal compromise server established the outbound C2 connection to the attacker's IP address. So we found all of these from our analysis here. Now when we actually do analysis, we create a lot of more information about what queries were used, why do we assume that this itself has happened. We basically create a storyline and try to mimic the actions of the attacker, which they might have used for compromising our servers. Now, the same thing is done in a summary there. Now, let's go to the questions section here. It talks about what is the attacker's IP found attacking and compromising the web server. So we have the attacker's IP address here. Let's copy that and paste it in here. Check if that's the attacker's IP. Oh, yes. Okay, which day was the peak web traffic? Format is YYMM DD. So it was on 2025 on October, if that is 10th, and then it was on the day of 12. It says mm, and oh, we need to also add in the hyphen there. So hyphen was missing. So let's click on check now. And yes, what is the count of this HaviG user agent event found in the log? It was around some 600, which I do not remember right now. So what we'll do is let's copy the same query, which would give us the user agent that we want to look after. Let's go to the one which directly gives it to us, or you know what, we can even filter it the other way, but I'm just looking at the possible filters which we can use. Let's say let's come down and can we get it here? We had seen it here, right? Recently, I am forgetting the command which we used. So okay, you know what, let's come here and just take this this query which just shows us the IP address, and from here we can just add in our own parameters there. So client IP address is this. Okay, let me replace it with the IP address. Let's copy the IP address of the attacker, then replace it here, and we don't need all these things. Let's press enter, and now let's go to the user agents here, and we have the number to be 993. I'm sorry, it's 993. So let's come down and found in the logs, which is 993. Let's make sure that's right. And that is indeed. So how many path traversal attempts to access the sensitive files on the servers were observed? That was around path traversal. Okay, which means the etc files. Let's once again use the query here. Okay, we had this query there. Let's copy this query itself. It was again 600 something. Let's replace this along with the IP address. Okay, let's copy the entire path. Come to Splunk here, then replace that with this. It's 658. Yes. Okay, now scrolling down, it's 658. 658. Now pressing enter. Yes, that's right. Examine the file logs. How many bytes were transferred from the C2 server from the IP address? It was something like 126.162. Do I remember it right? No. I want to try this. It was some number that I was it 4? No. Okay. let's not hit around the bush. Let's directly go there. Let's copy this, and we need to change the IP address too. So let's replace this here. Let's copy the IP address and replace it here. Pressing enter. We look at the bytes 126.167. So I was right with 126. It was 167. It was the least significant bit which I missed. So it is almost close. That's enough. I can consider that to be right itself. Now, if you enjoyed today's room, check out the incident handling with Splunk room to learn more about analyzing logs with Splunk. Yes. So we can click on check. And there we have finished the day 3 of Advent of Cyber with analyzing with Splunk. Let's click on continue and all these things. Let's just click on continue, go to where will. And what do we have for tomorrow? So tomorrow is day 4. So it's going to be AI and security, the old Saint Nick. Now, AI and security, I'm not too much hands on with it. I just know bits and pieces about AI being utilized in security. So I'm personally interested with what I'm going to be seeing tomorrow. So hope to meet you all tomorrow with the same power and energy of solving and hitting this I don't know cyber with the storyline that will we find Weevil at the last with Sokma celebration, and main thing, can we find Mixed Kitty? So that's the story that we'll be looking at the end of the advent of cyber. So till then, till tomorrow, stay happy, stay smiling. Thank you for watching. Bye bye. See you tomorrow.